Welcome to the AI Research Roundup. I'm Alex. This article presents a deep dive into Claude Opus 4.5, a new frontier large language model focused on software engineering, tool use, reasoning, and more agent-like behaviors. It shows that Claude Opus 4.5 can hit 80.9% on the SWE-bench verified benchmark while maintaining one of the strongest safety and alignment profiles reported for a frontier model, which is a striking combination. The publication is titled Claude Opus 4.5 System Card. And as we dig into the details later, the blend of raw capability and careful safety evaluation turns out to be especially thought-provoking. Moving on from the headline results, Figure 1.1.2.a shows differences in software engineering accuracy as the models are allowed to use more output tokens. The red Opus 4.5 line climbs from low to medium to high effort, which steadily raises SWE-bench verified accuracy from the mid-70s to just over 80%. The yellow Sonnet 4.5 point sits at a similar accuracy, but only at a much higher token budget, so Opus 4.5 reaches better results more efficiently. While that figure focused on token efficiency for software engineering, Table 2.3.a summarizes how Opus 4.5 stacks up across a broad set of benchmarks. Opus 4.5 leads the Claude family on almost every task, with especially large gains on Terminal Bench, Tau-squared bench retail and telecom, MCP Atlas, and OS World. Competing frontier models sometimes edge ahead on exams like GPQA Diamond and MMMLU, which shows that strengths differ by domain. The caption notes that these numbers average 5 trials with a generous thinking budget and interleave scratchpads, so the scores reflect the model's best-case deliberate reasoning performance. The previous table highlighted broad benchmark gains. Figure 2.6.2.a zooms into one browse comp plus agent setup. The bars show task completion rising from about 70% for plain Opus 4.5 to about 85% when sub-agents are enabled. Intermediate steps add context awareness, tool result clearing, and memory tools, which bring extra points. This pattern suggests that richer tooling lets the same base model handle browsing tasks reliably. While that Browse Comp Plus setup focused on web agents, Figure 2.10.a compares ARC AGI1 scores against cost per task for different thinking budgets. The orange Opus 4.5 curve climbs from roughly 40% with no extra thinking to around 80% at 64,000 tokens, so accuracy rises steadily as more computation is spent. Gray markers for GPT 5.1 and Gemini 3 Pro tend to fall below this curve, which indicates that Opus 4.5 often achieves better scores for a similar or lower cost. While that ARC AGI1 chart compared cost efficiency, Figure 2.10.b turns to ARC AGI2 scores versus cost per task. The orange Opus 4.5 points form a rising curve that reaches about 38% accuracy at the 64,000 token setting, which is the highest score shown. The gray GPT 5.1 markers stay lower at each cost level, so they deliver less accuracy for similar spending. A single Gemini 3 Pro point lands between medium and high Opus settings, highlighting that extended thinking especially benefits Opus 4.5 on this harder benchmark. While those ARCAGI results focused on abstract puzzles, Table 2.22.a compares web arena performance across several agents. Claude Opus 4.5 scores about 65% as a single policy model with general prompts, which is competitive but slightly below the specialized multi-agent systems. Claude Code plus Gbox and Deep Sky Agent reach around 68 and 67% by using multi-agent website-specific setups. The caption notes that all numbers come from the official Web Arena grader and average 5 independent runs, so the comparison aims to be fair and statistically stable. While after those agent benchmarks, Table 3.1.1.a shifts to single-turn safety on harmful requests. The table reports that Claude Opus 4.5 reaches an overall harmless response rate of about 99.8%, which is the best among the listed models. Claude Haiku 4.5 and Claude Sonnet 4.5 trail slightly, while Claude Opus 4.1 scores lower overall. Extended thinking keeps all models extremely safe, because even the weakest result is around 99.4% harmless responses across Arabic, English, French, Korean, Mandarin Chinese, and Russian. Compared with those harmful request results, Table 3.1.2.a turns to how often the models wrongly refuse benign prompts. Overall over-refusal rates stay below about 0.25% for every model, with Claude Haiku 4.5 lowest overall and Claude Sonnet 4.5 best in default and extended thinking modes. Claude Opus 4.5 is slightly more cautious, especially during extended thinking, which means it declines safe questions a bit more often. The caption clarifies that lower numbers are better because they indicate fewer unnecessary refusals across 6 languages. Compared with benign over-refusals, Table 3.5.2.a examines bias on the BBQ question answering benchmark. The table reports disambiguated and ambiguous bias percentages for 4 Claude models, where values closer to 0 are better because they indicate more balanced treatment across groups. Claude Opus 4.5 sits close to 0 on both measures, while Claude Sonnet 4.5 shows the largest disambiguated bias magnitude. Claude Haiku 4.5 has the highest ambiguous bias, so it appears more sensitive to unclear context. All scores use the standard, non-extended thinking mode. Those bias results were about fairness across groups, while Figure 4.1.a turns back to raw question answering performance on the 100 Q-hard set. The top chart shows that Opus 4.5 with thinking reaches the highest correct rate, around 46%, while other models cluster in the 34 to 41% range. The middle chart indicates that incorrect rates stay broadly similar across models, so higher correctness for Opus 4.5 does not come from simply guessing more. The bottom chart reveals that Haiku 4.5 and its thinking mode express much more uncertainty, whereas Opus 4.5 with thinking maintains relatively low unsure responses, which suggests more confident and accurate answers on difficult questions. Stepping back, the system card shows 2 big things. Opus 4.5 pushes frontier performance in coding, reasoning, and agents, and it does so under thorough safety evaluation with strong harmlessness and low bias. The broader message is that scaling capability must move with strong safeguards.